Another way of combining functions is to do a composite function. When you do a composite function, you are inputting the output of one function into another function. The composition of the function f with g is denoted by f of g of x. To find the domain of a composite function, combine the domain of the inside function with the domain of the result of your composition. In example 4, we have f of x equal to 3x minus 4 and g of x equal to x squared minus 2x plus 6. Part A, we want to find f of g of 3. Okay, and what that means, another way to write that, is f of g of 3, like that. So what this means is we want to take 3, input it into the function g, and once we get a solution for that, we want to input that into the function f. So this is the part where I described inputting the output of this function into this other function. So we want to start this problem by finding g of 3. So 3 squared minus 2 times 3 plus 6. This is 3 squared is 9 minus 6 plus 6, and that equals 9. So I want to take that output from g and now input that into the function f. So f of 9 equals 3 times 9 minus 4, and that is 27 minus 4, which is 23. So f of g of 3 is 23. In part B, we're asked to find f of g of x. Okay, so here we're not given an input for the function g. We want to take all of the inputs. Okay, so we want to leave g as a function, and we want to input that into the function f. Okay, we did this somewhat in a previous section when we evaluated functions. We just didn't call it composition at that time. Okay, so what we want to do is take the function f, 3x minus 4, and everywhere there is an x, we want to input the function g. So instead of 3x, 3g minus 4. Okay, and then from there, let's go ahead and put in what the function g actually is. So we'll have that equal to 3, and then in parentheses, the function g, x squared minus 2x plus 6, and then finishing the function f minus 4. So everything that is in red is what used to be just x in the function f. So again, this is telling us to take the function g and input it into the function f. That will give us every composition for f of g of x. Okay, so now simplifying using the distributive property, 3 times x squared is 3x squared. 3 times negative 2x is minus 6x. And 3 times plus 6 is plus 18. And then outside of the parentheses, we still have the minus 4. Simplifying, 3x squared minus 6x, 18 minus 4 is 14. Okay, for the domain, We want to combine the domain of the inside function with the domain of our composition. The domain of our inside function, since there's no square roots and no denominators, is all real numbers. And the domain of our solution, since there's no square roots and no denominators, all real numbers. So the domain of our composition is all real numbers. Okay, in part C, we're asked to find g of f of x. So here, we want to take the function f, and since there's no specific value given, we want to input the function f into the function g. So take the function g, and everywhere that there is an x, replace it with an f. So this will equal, instead of x squared, f squared, minus 2, instead of x, f, and then plus 6. Replacing f with the actual function f gives us 3x minus 4 squared minus 2 times 3x minus 4 plus 6. So again, everything that is in red is what was x in the function g. And so now we need to simplify this. Remember that this is a FOIL problem. 3x minus 4 times 3x minus 4. Okay, if you FOIL that out, you will get 9x squared minus 24x plus 16. I went ahead and combined my two middle terms from FOIL. Use the distributive property. Minus 2 times 3x is minus 6x. Minus 2 times minus 4 is positive 8. And then plus 6. Combining like terms, 9x squared. Negative 24 minus 6 is negative 30x. And 16 plus 8 plus 6 is 30. Since function f has no square roots and no denominator, its domain is all real numbers. And our result from doing the composition, no square roots, no denominators, so its domain is all real numbers. So the domain, combining those two together, negative infinity to infinity. Example 5, we have f of x equal to 2 over x minus 1, and g of x equal to 3 over x. And in part A, we are asked to find f of g of x and to also state the domain. So we want to take the function f and input g into the function f. So 2 over, instead of x minus 1, replace x with 3 over x. Okay, and then we want to simplify this. So if it helps, think of this 1 as 1 over 1. And since we have a fraction within a fraction, what we want to do is look in the big denominator and identify the common denominator of these smaller fractions. So x and 1 is the common denominator, so x. So we want to go ahead and multiply our big fraction, top and bottom, by x. In the numerator, that gives us 2x. And in the denominator, x times 3x, the x's will cancel, leaving 3. And x times minus 1 over 1 is minus x over 1. And the denominator, it doesn't do anything because it's just a 1. So minus x. So f of g of x is 2x over 3 minus x. For the domain, we want to combine the domains of the inside function, which is g, with the result that we got. So for the function g, 3 over x, if x is 0, we're dividing by 0, so we want to exclude 0. And 3 minus x, if x is 3, we would have 3 minus 3, so we also want to exclude 3. So our domain is negative infinity to 0, 0 to 3, and 3 to infinity. Part B, we're asked to find g of f of x. Okay, so g of f of x, we want to take the function f and input it into the function g for everywhere we see an x. Okay, so rather than 3 over x, we'll have 3 over f, which is 2 over x minus 1. Okay, so again, instead of 3 over x, 3 over f. Okay, to simplify this, since the denominator is one single fraction, we're dividing 3 by a fraction. And when you divide by a fraction, it's the same as taking 3 and multiplying by the flip of this number, which would be x minus 1 over 2. So again, when you divide a number by a single fraction, unlike a, this is a single fraction, we can take this bottom fraction, flip it, and now it's a multiplication problem. Using the distributive property, 3 times x is 3x, 3 times minus 1 is minus 3, all over 2. Okay, for the domain, we want to combine the domain of f with the domain of our result. The domain of f, you have x minus 1 in the denominator, so x cannot equal 1. And for our result, we have a denominator, but there's no x in our denominator, so we don't get anything additional to exclude from our result. So x can just not equal 1. Okay, so we're going to get negative infinity to 1, union 1 to infinity.